So let's talk a little bit about finding the slope of a VT graph. This is important because the slope of a VT graph gives us the acceleration. That's really the change in the velocity of the object over time. And because we have a vector quantity, that means that the acceleration is going to have two parts. It's going to have a magnitude, how fast the object's accelerating, and it's also going to have a direction. Is it accelerating in the positive direction or the negative direction? And we can find both of those things from the slope of the VT graph. Now, just a quick reminder, the direction of the acceleration is not necessarily the direction the object is moving in. That would be the direction of the velocity. The acceleration is what direction the change in the velocity is in. And we'll talk more about that another time. So in order to find the acceleration on a VT graph, we just need to look at the slope. And so we will do a quick slope calculation. For example, let's look here from about 30 seconds. I'm going to make it purple too. About 30 seconds to about 60 seconds. I need to know the acceleration over that time period. So I'm going to do a quick slope calculation. For that calculation, this is going to be the initial point that I'm going to use. And this is going to be the final. The initial comes first and the final comes last. And that's my dog growling in the background. So all I'm going to do, remember the slope is the rise over the run. That's the change in the y values divided by the change in the x values. But because we don't need to use y and x, we have actual variables on our y and x axis, so we'll substitute those in. And that gives us the change in the velocity over the change in time, which is the definition of acceleration. So change in velocity is just the final velocity minus the initial velocity. Change in time is just the final time minus the initial time. So I'm just going to plug my numbers in here. So from my final point, my final velocity, I'm just going to come over and I'm going to read it right off of the y-axis there. That's going to be -3. It's important to watch the sign of the values. And then my initial velocity, I'm just going to read that right here. That's going to be a +6. So I have v final, which is -3, minus v initial, which is 6, divided by the time, which is 60 seconds, minus 30 seconds. And again, I'm just reading right down off the graph. So I have -9 divided by 30. I'm going to do a quick calculation on my calculator just to get that into decimal form. And that gives me -0.3. And my units for the acceleration are meters per second squared. This is the slope of this VT graph from 30 to 60 seconds, and that is equal to the acceleration. Now, it's important to note that the acceleration does not tell you the direction the object is moving in. For example, here, for this entire part of the graph, so from 30 to 50 seconds, the velocity is positive because the velocity is above the horizontal axis, and that is the positive velocity part on the graph. At the time that the velocity is positive, the acceleration is negative. And remember, when the acceleration and the velocity are in opposite directions, the object is slowing down. And sure enough, if you look at the velocity starts at 6 meters per second, and at 50 seconds, the velocity has gone to 0. So it has slowed down. In that final 10 seconds here, from 50 to 60 seconds, the velocity is negative because we're below the horizontal axis, the 0, and the acceleration is still negative as well. And when velocity and acceleration are in the same direction, that means the object is speeding up in that direction. And sure enough, at 50 seconds, we have 0 velocity, and at 60 seconds, we have negative 3 meters per second, or 3 meters per second of speed in the negative direction. So it's important to keep that sort of clear. Velocity and acceleration are different. The velocity does tell you the direction the object's moving. The acceleration tells you the direction of the change in the velocity. Now it's your turn.